Hello everyone, welcome to this online tech session on Elastic Kubernetes Service. My name is Yannick Siewe. I am Cloud Solution Architect at Adorsys. I previously worked as lead DevOps for automation and as a system development engineer focused on writing script to monitor computer process and run database backup. In my current role, with a strong background in cloud infrastructure and container services, I interact with customer, product manager, and developer to design and model solutions for customer to adopt the cloud platform. Feel free to contact me if you have any question about adorsys cloud services, container services, or adorsys services in general. This is our level 1, demystification of the Amazon Elastic Kubernetes service. In this first video, we will talk about the overall architecture of the Amazon Elastic Kubernetes service, and other video will follow concerning the understanding of the network in depth, as well as explain how EKS handle authorization and authentication. And the last one will be dedicated to security good practice based on the Amazon shared responsibility model. First of all, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. Amazon EKS is certified Kubernetes conformant, which means existing applications that run on upstream Kubernetes is compatible with Amazon EKS. So Amazon EKS is Amazon Kubernetes management infrastructure, and it's made up of a few main components. The first one is the network. An EKS cluster consists of two VPC. Amazon managed VPC that hosts the control plane, and customer managed VPC that hosts the Kubernetes worker node where the container run, as well as other Amazon infrastructure such as load balancer and network interface used by the cluster. A VPC can contain all public subnet or a combination of public and private subnet, and must reside full in one availability zone and cannot span multiple zones. A subnet is public or private depending on if the traffic inside the subnet is routed through an internet gateway. If the subnet is associated with a route table that includes a route to an internet gateway, then it is a public subnet. If a subnet is associated with a route table that does not have a route to an internet gateway, then it is a private subnet. That's it. Let's talk about our second component, which is the control plane. When create a cluster, the control plane is deployed on the dedicated set of EC2 instances and managed by EKS in the Amazon Managed VPC. Control plane run in single tenant mode and take care of Kubernetes master component like API server, scheduler, controller manager, and etcd server. By design for resilience, scalability, and high availability, Kubernetes master nodes are distributed across 3 availability zones in the same region, and the traffic to and from internet is managed by Elastic Load Balancer. At the time you create the cluster, Amazon EKS create and manage network interface in the customer account. That network interface is used to allow worker node to communicate with the control plane. By default, control plane expose public IP so that client tools like kubectl used by the cluster administrator can communicate with the cluster. Optionally, you can enable the private endpoint and disable the public endpoint, or enable both the public and private endpoint. In this case, API requests from the customer VPC communicate with the control plane by using the network interface through an private hosted zone. Then, our next component is the worker node. Kubernetes worker node run with EKS and Fargate instance in the customer managed VPC. The worker node is deployed on a subnet and assign a private IP address from the site block allowed to that subnet. The node uses the API endpoint to communicate with the control plane through a unique certificate file created for the cluster. For reliability and resilience of the application running in the worker node, cluster autoscale is used to adjust the size of the data plan. The scaling activity is performed either in the single availability zone or across multiple availability zones. When some pod cannot run because the cluster has insufficient resources, the autoscaler adds another worker node to meet the demand, and new container can then be scheduled inside this node. That's it. The last component for this video is the elastic load balancer. Amazon EKS load balancing network traffic to port deployed in the worker node using elastic load balancer. Its configuration is controlled by annotation added to the Kubernetes service manifest. The network traffic is balanced at the layer 4 and application load balancer traffic at layer 7 of the OZ model. When using the Amazon VPC CNI plugin, the Amazon Load Balancer controller can balance traffic to worker node instance IP or target. When using alternative CNI plugin, the controller can only balance traffic to instance target. Elastic Load Balancer route application traffic to and from the internet for customer through the subnet associated with the route table that has a route to an internet gateway. Thank you for watching. This was all about the overall architecture. In the upcoming video, we will talk about EKS network concept. Don't forget to subscribe to be informed when we push out new video.